Hi everyone, welcome back. Today we are going to be talking about significant figures. And in the last lesson, we added this extra decimal point when we were reading these numbers. And today we're going to talk about why we do that. So we always need to show uncertainty in our measurements. And what I mean by that is let's just practice what we learned from yesterday's lesson. So if we were to read this cylinder, we would read it going up. So we've got a number between 20 and 25. So as we said in the class before, we always read the bottom of this dip. Pretend that I can draw straight lines, because I can't. So if we were to read this, we know that this goes 20, 21, 22, 23, 24, 25. Well, we can read between these lines and we say, well, it's not quite 21 and it's not quite 22. It'd be inaccurate to say it's either one of those because it's right between those. So what we do is we always add one extra decimal point. So we say that that's about 21.5. Could it be 0.4? Sure. Could it be 21.6? Absolutely. We don't have lines to indicate to this level of accuracy, which is why we need this extra decimal point past what we can read. Okay, so that's what uncertainty is. Now, as I said, we're going to include all known digits. So we can read up to 21 and between it. So what we need to do is we need to indicate that unknown digit, which is the one the arrow is pointing to. And we will talk about this in class through a discussion. Don't worry about turning and talking because you're obviously watching this yourself right now. Now, in order for us to communicate this effectively, we're going to use a method. So while I clear the screen, clear all drawings, we're going to use this box of the United States. So in the United States, we'll just pretend that, oh, my pen just messed up. We're going to treat that as a box. Just one big box. And over here on the left side, we have the Pacific Ocean. That's near like California. And on the right side, near us in New York, we have the Atlantic. In other words, we have a P on the left side, A on the right side, just taking the first letter. And in order for us to communicate this uncertainty, we're going to use a method building off this. So you might be watching this thinking, I have no idea what he's talking about right now. Bear with us. It's going to make a little bit more sense when I get to the next slide. So I'm going to clear these drawings. So we need to be able to determine the number of significant figures in a certain drawing, or in a certain number, excuse me, I'm sorry. So let's say I give you a number, and I tell you that number is 115.6. So we need to figure out how many of these numbers are significant. And we're going to use what's called the Pacific Atlantic method. So what we're going to do is we're going to create a box. And we're going to put that number in the box. That's this first step. Well, I said that it is 115.6. So on the left side of our map, if we remember, we've got the Pacific. And we've also got on the right side the Atlantic. Or in other words, we've got P on the left side, A on the right side. Well, we need to ask ourselves, is the decimal present or absent? So on the left side, we've got present. On the right side, we've got absent. So if the decimal is present, we're going to start from this left side. And we're going to draw a line until we hit a non-zero number. So we're going to go, and eventually we're going to hit this number right here. This number is not 0. So we are going to stop right there. Now we're going to count every number after it. Well, we've got 1, 2, 3, 4. So we say that this has 4 significant figures, or sig figs. I'm going to walk through a couple of more examples just because I think this is very confusing at first, but once you get the hang of it, it's going to become a lot more clear. Speaking of clear the drawings. Write the number in the box. So let me give you a different number. Let's say I give you 0.00401. So let's draw our box. 0.00401. We need to ask ourselves, is the decimal present or absent? Well, we can see that there is a decimal here, right there. So the decimal is present. So we're going to start from this left side. And we're going to go until we hit a non-zero number. We're going to go, and this is 0. That we keep going, keep going, keep going. There. There is our first non-zero number. So we're going to start counting right here. So this is 1, 2, 3. 3 of these numbers are significant figures. Remember, we're counting all the numbers after we hit this first non-zero number. Now, let's run through an example where the decimal is absent. So I'm going to clear this one more time. So let's do 301,402. Doesn't really matter the number. So let's put our number in the box again. So we've put the number in the box, check. Is the decimal present or absent? Or in other words, is there a decimal here? There is no decimal here. So we'll say that the decimal is absent. So we're going to start from the right side this time. And we're going to go until we hit a non-zero number. Well, 2 is not 0, so we stop there. So we drew the line until we hit that non-zero number. We're going to count the numbers after. 1, 2, 3, 4, 5, 6. There are 6 significant figures. We're going to go over more examples in class today, but these are your significant figures notes. And in class tomorrow, you will determine how many significant figures are in these numbers. Hope you have a good day, and I will talk to you all tomorrow.